Hey, this is Mr. Warden. I'm going to work a few problems from this worksheet using the substitution method. So I'm going to start off with number 1 here. And what I want you to do before I start off is you should pause the video and see if you can do this one and make some headway on it. Assuming you have paused. And that's how you will get the most out of these videos, is if you pause the video and try working the problem. If you get stuck, unpause it and let me talk through a little bit. And once you start to feel unstuck, pause it again. And even if I haven't finished working through the problem, and see where you get to. I think that will help you a lot, both with not glazing over while you're just receiving a video, and also in terms of engagement and building your own confidence, finding the pitfalls that might lead to an error and so forth. So here's what I'm going to do. I'm going to assume you have paused. So I know you paused. I know you want to get the most out of these videos and figure out how to do this yourself, which is much more interesting than just having me do the problem, and you'll get more out of it. So I'm going to assume you pause, and I'm going to go ahead and start solving number 1. So number 1 is very conveniently has already isolated y. So what I can do is, where in the other equation, I can replace y with that expression. Because in a system, I want y to be the same in both equations, and that will allow me to figure out what x would be when it's also the same in both equations, what the value would be. So I can take this expression for y, and I'll replace this y with it. So I'm going to rewrite this as negative 2x minus 3, and then in parentheses, instead of y, I'm going to have 6x minus 11. Okay, and then I still have, of course, equals negative 7. Okay, so let's start simplifying this. The first thing to do is distribute this negative 3. I'll have negative 2x still. And the negative 3 times 6x is going to be negative 18x. Okay, so that becomes a minus 18x. The negative 3 times negative 11 is going to be plus 33. And that still equals negative 7. All right, so I'm going to combine my like terms. Negative 2x minus 18x is negative 20x. And then I can subtract 33 from both sides. So one-stop shopping. If I take 33 away from both sides, it goes away here. And over here, it becomes negative 40. And you can see this is going to end up being fairly neat and tidy. Now we'll divide both sides by negative 20. And x will end up equaling 2. Okay, so now that I know what x is, I can go back and plug it into my original equation. And I'll say y equals 6 times what I know x will be, which is 2, and then subtract 11. Okay, and at this point, we've got 12 minus 11. Y equals 12 minus 11. So y equals 1. Okay, so now I know y is 1, x is 2. My solution is 2, comma, 1. Okay, so just to recap, I grabbed this expression, which was already given to me because y was already isolated. I plugged it in to replace y with, so y became 6x minus 11. I now have just one variable to work with, and I solved for x. Once I knew what x was, I went back and substitute x. The x is 2 here, and I now have y equals 6 times 2 minus 11, and that leads to y equals 1. Now I have erased all of that, and I'm going to go on to one that might take a little bit more work. Okay. Let's see. One that will take a little more effort. This one will take a little more effort here. Number 18. We'll do number 18 now. Now, number 18, you will notice that nowhere is a variable already isolated for you. So you really just need to figure out which variable will be easiest to isolate. I think that this x and the negative 2x is going to be the easiest to isolate because it will end up giving me an expression that has no fractions. So I'm going to start by doing that. So I'm going to take this equation, I'm going to move it over here, and I have negative 2x plus 6y equals 6. So the first thing I'm going to do is I'm going to take the 6y, I'm going to take the 6y, I'm going to subtract 6y from both sides. That's going to make this 6y go away on this side, and it'll end up over here. So that'll end up giving me negative 2x equals 6 minus 6y. Then I need to divide both sides by negative 2. So x will end up equaling negative 3 plus 3y. And now I have an expression. Let me tidy that up. I have an expression for x that I can plug into the other equation. So that expression is this expression here. I'm going to substitute in for this x. I can't substitute it in for this equation because I got it from this equation. And if I put it back in, it's just going to turn this equation into 0 equals 0. That's not going to give me anything useful. What I want to do is I want to find out what y is using the other equation. So let's go ahead and do this. So I'm going to have negative 7 times this negative 3 plus 3y. And I trust you paused the video to try it yourself already. If you haven't, go ahead and pause it and see what you can do from here. I won't always remember to remind you to do that, but I remind you to do that now. So now I've got this new equation. I have replaced x with this expression for x, and now I have an equation that only has one variable. It's y. So I'll distribute the negative 7. Negative 7 times negative 3 is 21. Negative 7 times negative 7 times 3y is negative 21y. And then I've still got plus 8y equals negative 5. I'm going to move my face up here. Okay. So now, let's go back and keep going. So I'm going to combine my like terms. Negative 21y and 8y is going to be negative 13y. Okay, so there's a negative 13y here. I'm going to subtract 21 from both sides, so I get rid of that. So negative 21 and negative 5 is going to make negative 26. Ooh, that's a convenient number. Now I'll divide both sides by negative 13. Negative 26 divided by negative 13 is 2. And now I can go ahead and take the y equals 2. If I wanted to, I could substitute it in for either of these y's. But why would I do that if I've already figured out an expression for x? So I'm going to actually plug that 2 in to this expression for x and find out what x is. So x will end up equaling, I'm substituting the y value. So x will equal 3, negative 3, plus 3 times 2. And so that's negative 3. That's 6. negative 3 plus 6 is going to equal positive 3. So I have a solution at x is positive 3, y is 2. All right, I'm going to stop there. I will probably make a couple more videos of just working through problems to model that for you. But I hope that helped. If you're wondering how I found this worksheet for practice, it's pretty easy. I just did a search for systems of equations substitution worksheet, and I found worksheet. If you put with answers, it'll give you answer keys so you can check your work and practice this thing. Really, with mathematics, when you're learning a new thing, just going over it is not going to get you a full understanding. Actually doing practice will do that. So grabbing things to practice with, using the practice things that I may have provided you, will help you an enormous amount in understanding how to do this sort of thing. Okay, I hope that was helpful.